Okay, so the title of this talk is highly qualified, except it's not. I changed it because I thought I need to do better search engine optimization. So I call it David Stone is highly qualified. Now when you search for David Stone on Google, this is what'll show up. Okay, so we all know about the east versus west const debate, right? So you have constant, this is west const, and then int const, this is east const. But I don't know about you guys. I don't think this is like very important. This isn't something we should spend our time on. Like, so let's kind of go back and think about what is important. How to get a job, making money, okay? They ask you, are you qualified? And show me your CV. So, with north const, you can say I'm highly qualified. Very highly qualified. You can be as highly qualified as you want to be. And now, of course, if there's a north const, there has to be a south const. But I don't know about you. That feels, I don't know, it's not balanced. That's where we have central const. Perfectly valid C++. Perfectly valid? Perfectly balanced, as all things should be. Now, I don't know about you, but this is C++. That's kind of disappointing. Like, we have const and we have volatile, and we're treating them the same way, but they're fundamentally different. We need something better. We need something more effective. That's where we get alphabetized const. I want to talk about requires. Okay, so we have this keyword, requires. Many of us are familiar with it. The purpose of the requires keyword is you can put it on a template, and if that requirement is true, then the template is usable, otherwise it's not. And that is the meaning of the requires keyword. Now I want to talk about a completely different keyword. I want to talk about requires. Okay. So the requires keyword is used to create a constraint. You just define a concept. You put some stuff in the body of the requires block, and if that code is valid, then the concept is true, and if the code is invalid, then the concept is false. Okay? Now, you can do this. You can combine a concept with a Boolean expression. This is what you normally do. But I don't really like this because you have to learn about requires, and you have to learn about and. Like, that's way too complicated for me. I'm a simple guy. I like just one thing. I only have to know requires with this syntax. You can say requires, and then inside the body of a requires block, you can say requires Boolean expression, and the concept evaluates to true if this is true. Now, this is C++. We like to generalize things. You don't have to just do this once. This is the same as the previous example, and first of all, but this is C++. We can do this once. We can do this twice. And let me reformat that for you, make it easier to read. Anywhere that you see requires, it is actually perfectly reasonable in C++, asterisk, reasonable, to add two more requires without changing the meaning. And so when you format it this way, it's really friendly because you can see requires, open curly brace requires, and as many of those as you put in, you add one of these fancy smiley faces at the end. Because that's the expression on your coworker's face when they see this code. Okay, and then we also have the other keyword I talked about, requires. That has the same property as requires. Anywhere that you see requires, you can add two more requires, and that's perfectly fine. The curly brace goes on the other side because it's a different keyword, but you still have that little smiley face at the end for your coworkers. And now it's actually possible to remember this example, our friendly show us the keywords. We can combine these two concepts into one. We can make this as large as the code needs to be to impress the people interviewing us. We'd be like, look how highly qualified I am. I think I am the most highly qualified programmer ever right here. And I think that's all I have. Thank you.